adjoint and inverse of a square matrix. If A is a square matrix of order 3, then what will be adjoint? So adjoint matrix will be transpose of the matrix of cofactors in the same fashion as the elements A11, A12, A13, A21, A22, A23, A31, A32, A33. In the similar fashion, we will put all the cofactors in the matrix. In the first row, cofactors A11, A12, A13, and in the first row A11, A12, A13, in the second row A21, A22, A23, and in the third row A31, A32, A33. And then we will take transpose. After taking transpose, we will get the first row will be changed into a first column, and the second row will be in the second column, and similarly the third row will be changed into a third column. And this matrix is basically adjoint matrix. And how we can find the cofactors A11, A12, A13, A21, A22, A23, that I have explained in the previous video. Any cofactor Aij can be found by Aij is equal to -1 raised to the power I plus j. If I plus j is odd, then the result will be -1, and if I plus j is even, then the result will be +1, and then we will multiply this +1 or -1 with the mij, minor ij. What is ij? Ij is I is 1, 2 or 3 in this case of the matrix of order 3, and j 1, 2 and 3. So we can put I and j in, for example, we are taking I is equal to 1, then we can put j with it 1 or 2 or 3. Then if we put I is equal to 2, then again we can put j 1, 2 and 3. Similarly, if we put I is equal to 3, then we can put j with it as 1, 2 or 3. So we will get how many cofactors? 9 cofactors. And we will put these 9 cofactors in this matrix in this fashion. First column is A11, A12, A13, and second column A21, A22, A23, and third column A31, A32, A33, and thus we get adjoint of A. How we can find determinant of A? Determinant, I have explained it also in previous video, that if we expand the determinant by first row, then determinant of A will be A11 element multiplied by its cofactor A11 plus A12 element out of the first row A12 and A13. So A12 plus A12 multiplied by cofactor A12 plus A13, the third element of the first row, and its cofactor A13. So this is the way how we can find the determinant of A if we are opening it with the first row. If we are opening with the second row, third row, second row or third row, or if we are opening it with the first column, second column or third column, then there are methods. I have explained it in the previous video, you can watch it. So how we can find the inverse? The inverse formula is this: A inverse is equal to 1 over determinant of A multiplied by adjoint of A. So adjoint we can find by this method and determinant by this method. So let's see the example. The example is, find A inverse if A is given a 3 by 3 matrix or a square matrix of order 3, 1 0 2 0 2 1 1 minus 1 1. So we are finding now the cofactors A1 1. Since 1 plus 1 is 2 even, so we will put a plus sign over here. As I have told you over here, if I plus j is even, then here will be plus 1, and if I plus j is odd, then here we will put minus 1. So I have put plus 1 over here, and then since it is the cofactor with respect to the element A11, so this is the element A11. With respect to this, we are finding this cofactor. So we are highlighting this element, and where this element is in the row and in the column, both row and column will be hidden. And what are the elements left? 2 1 minus 1 1. And we will open this determinant. So 2 minus, and 2 multiplied by 1 2, minus 1 multiplied by minus 1 minus 1. So 2 minus minus 1, which is equal to 3. In the similar way, A12 with respect to the element A12. So this element is highlighted, and the row and the column having this element will be hidden. And what are the elements left? 0 1 and 1 minus 1 1 1, 0 1 1 1. So these will be put in the determinant, and here we will put minus because 1 plus 2 is odd, so minus 1 will be here, or minus will be here. So open it, minus multiply by 1 into 0 0 minus 1 into 1 1. So 0 minus 1 minus 1 minus 1 multiply by minus plus 1. Now A13, the third element 2, so you will highlight this element, and the row and the column having this element will be hidden. And what are left? 0 2 and 1 minus 1, and plus sign will be put over here because 1 plus 3 is 4, which is even. So minus 1 into 0 0 minus 2 into 1 2. So 0 minus 2 is minus 2. Now A21. A21 is this element. So this element is taken, and the row and the column having this element will be hidden, this row and this column. So what are the elements left? 0 2 minus 1 1, 0 2 minus 1 1, and minus sign is put over here because 2 plus 1 is 3. So minus, and 0 minus 0 into 1 0 minus 2 into minus 1 minus 2. So 0 minus minus 2, 0 plus 2 2. So minus into 2 is minus 2. Now take this element, which is A22, and what are the what is the row and the column? having this element will be hidden. So what are the elements left? 1, 2 and 1 minus 1, 1. 1, 2, 1, 1. And plus sign is put over here because 2 plus 2 is 4 even. So this one minus 1. Now A23 cofactor with respect to element A23, this one. So the row and the column having this element are hidden, and then what are the elements left? 1, 0 and 1 minus 1. 1, 0 and 1 minus 1. And minus sign is put over here because 2 plus 3 is odd. So the answer is 1. Now A31 with respect to this element, the row and the column having this element are hidden, and then 0, 2, 2, 1 are put in this matrix, and plus sign is placed over here because 3 plus 1 is 4. Now A32 with respect to this element A32, and this column and this row are hidden, then 1, 2 and 0, 1. 1, 2 and 0, 1, this thing, and minus sign is put over here because 3 plus 2 is 5, which is odd. Now A33 is this element, so the row and the column are hidden, and the elements left 1, 0, 0, 2 are put over here, and plus sign is placed because 3 plus 3 is 6, which is even. So all the cofactors we have found are put in this matrix. Adjoint of A is equal to A11, A12, A13, A21, A22, A33, cofactor A31, A32, A33. And we have put all these elements over here in the places of cofactors. So we have found in this way adjoint of A. And this matrix of adjoint of A we have already explained over here. Now determinant of A is found by A11 capital A11 plus A12 capital A12 plus A13 capital A13, because we are opening this determinant now with respect to first row of A. This is the first row. So 1, 0 and 2, A11, A12, A13. So now putting the values of A11, A12, A13, which are 1, 0 and 2. Now capital A11, A12, A13, capital A11, 3, capital A12, 1, capital A13, minus 2, so 3, 1, minus 2, 3, 1, minus 2. So now multiplying 3 with 1, 1 with 0 and minus 2 with 2, we are getting 3 plus 0 minus 4, which is equal to minus 1. So this is determinant of A. This one is adjoint and this one is determinant. Now we are finding the inverse. How we are finding the inverse? The formula is A inverse is equal to 1 over determinant of A multiplied by adjoint of A. Determinant of A we have just found, which is -1, and adjoint of A is this matrix. 3 minus 2 minus 4, 1 minus 1, 1, minus 2, 1, 2. Now this 1 over -1 is basically -1. So -1 is multiplied inside with each entry of this adjoint of A. So we are getting this thing, and this is the inverse. Now how we can check whether this is the inverse of A? We will multiply it with A, and if we are getting identity matrix of order 3, then we are saying that it is the inverse of A. The inverse of A is given in the question 1, 0, 2, 0, 2, 1, 1 minus 1, 1. And adjoint of inverse of A we have just found minus 3, 2, 4, and minus 1, 1, minus 1, 1, 1, 2 minus 1, 2, 2 minus 1 minus 2. So we are putting putting A inverse over here. So A multiplied by A inverse. When we multiply the first row with the first column, we are getting this thing. First row with the second column, we are getting this thing. First row with the third column, we are getting this thing. Now second row with the first column, getting this thing. Second row with the second column, getting this. Second row with the third column, we are getting this. Now third row with the first column, getting this. Third row with the second column, getting this, and third row with the third column, getting this thing. How we are multiplying each row with the column? For example, 1, 0, 2. This is the first row, and minus 3 minus 1, 2. This is the first column. How we are multiplying? 1, 0, and 2. This is the first row, and this is the first column, minus 3, minus 1, and 2. Now multiply minus 3 with 1, minus 3, minus 1 with 0, 0, 2 with 2, 4, and now we are adding. So we are getting this thing, minus 3 plus 0 and plus 4. After adding, calculating each entry of this, we are getting 1, 0, 0, 0, 1, 0, 0, 0, 1. So A multiplied by A inverse is equal to the identity matrix of order 3. Thank you.